CQ, CQ contest, CQ contest. Whiskey 0 X-ray Mike, W0 X-ray Mike. November 5, Oscar Lima Alpha. Name is Bob. It's Canada 4 Papa.
This is a single bander. It's the HW-22. I was on my Heathkit Facebook group today and somebody said, you know, I don't see any videos on single banders. And I thought, well, I've got about a dozen of them. Why don't we just get one and crack it open and see if we can make it work? This is one that I restored last year. This is the 20 meter version. Up here we have the 40 meter version, and I've also got some 80s. I'm never on 80. I don't have an 80 antenna, so I don't have any in operation. But Heathkit put these out between 1966 and 74, and basically it's a mobile transceiver. If you are driving your Ford Comet or whatever, and you want the power of an HW-101 or something like that, you can have it in a single bander, just one band. This has 100 watts output, and it's got a really good receiver, and it's small, and it's kind of easy to work on too. It has the tuning mechanism that you'll see in the HW-100. I really love these little radios. This is my Heathkit graveyard, formerly known as a guest room. And here's some of my mono banders, or single banders. And I think I'm going to choose that one. Let's see which band it covers. They all look exactly alike. You have to actually look at the dial to know which band it covers. I see there's a little piece of tape that says OK. I don't know when I put that on there. I must have fired it up at some point. It's in good shape. Cabinet's nice. Just needs to be cleaned up. All the knobs look good. The thumb switch is intact. And the dial is good. You always want to be sure that that plastic dial is okay. You can't get these anymore. You can get them for like the HW-101 or the HW-16. The single banders, no one has yet put out replacement dials. So if yours is cracked, you might have to just tape it back together. It's kind of amazing that this radio has as much output as one of those HW-101s. They're so small and so light. I mean, they're just babies. Okay, it looks like I rated it for that 10 PF cap at some point. So I'm just going to go ahead and replace that, fire it up and see what happens. Obviously, we want to give this a nice cleanup. The board is really grimy, but we kind of expected that. You know, it's no big deal. I'm going to pull all the tubes. I'm going to give it the sink scrub. I'm going to replace that paper cap right there. I'm going to replace any other electrolytics that I find, test all the resistors, but first, let's see if it runs. Luckily, I have an original manual. You got to have a manual to do this. If you don't have one, get a PDF online or buy one on eBay. Look what I found. 1969. It's been in here so long, it left an impression on the page. I love that. Love those little discoveries. Here's another discovery I made. This is totally off topic. Where'd it go? Here it is. I was working on a Precision 920 tube checker from 1940-ish, and it had the original resistance check battery. And look at the date. 1924. Isn't that cool? It's got 2 volts in it. I checked it. Has no current. Those volts aren't going anywhere, but what a cool little artifact. Unless you're running this rig in your 1965 Ford Comet, you need a power supply. That power supply needs to have a switchable low voltage setting, and we want to switch it to the 250 low voltage. I've got my full complement of tubes, and let's see what happens. That's the first good sign. We want to see that meter come back to 0 as the tubes warm up. Well, it's not happy. Didn't really expect it to work on the first try, but it would have been nice. I don't know why these rigs have LSB USB settings. You always want to be on USB when you're on 20 meters, but whatever. Well, no signal coming through. But it didn't blow up. Nothing smoked. So, good start. Ah, there we go. That's promising. Come on. Come on.
CQ2 November X-ray 6 Tango.
Isn't that beautiful?
CQNA November X-ray 6 Tango.
All right. That is cool. That's going to really cut down our workload considerably. Okay, step one, remove all the tubes. I'm going to go ahead and remove this paper cap. I think that's it. And I'm going to give it the sink scrub. Okay, stop the presses. We're not going to restore this radio. It's already working. Maybe we'll have some challenges getting it to transmit, but this is a how-to video. We need something with a little more complication. So how about this one? This is the predecessor of that one. That's the HW-22A. This is the 32. This one is telling me I'm sick. I've got a lot of problems. That's what we want. So what's different? Well, the knobs are different. Obviously, these are knobs that you would find like on a HW-16. See that the function switch is on this side. Electronically, they're very, very similar. This one's more attractive, I think. But hey, these are good radios. Let's look inside. Cabinet is okay. It's a little rusty, but we can take care of that. Another difference, it doesn't have an 11-pin socket. It has an 8-pin octal socket. Also, the microphone socket is on the back, not the front. They figured out later on that since these were being put in cars, they should probably put the microphone connection on the front. This may be the first time this rig has been opened in a very long time. There she is. Okay, much dirtier. That's more like it. Oh, look at that. Wonderful. We want challenges. And this one came with the crystal calibrator. That's interesting. Okay. I don't know. Should we fire it up and see what happens? For this, we'll need an 11-pin male to an 8-pin female cord. This is not good. The registration pin in the middle of that socket broke off. So we're going to have to be very careful. Antenna socket is a BNC, which I don't particularly like, but I do have a BNC adapter. Okay, we're all hooked up. Let's turn it on, see what happens. Stand back. And nothing happens. Oh, that's because my power supply is off. Okay, take two. Uh-oh, there's fire. Okay. That's weird. I didn't even turn it on yet and it's already smoking. You can see the shape of the tab where it broke off, pointing down. That's what we would expect. Well, after a bit of more research, I realized this cable is wired wrong. The bias, which should be going to pin 1, is actually going to pin 2. And that's why we were seeing smoke, because we had power going to the rig and it was bypassing the switch. Oh man, that could have been bad. I don't even remember where I got this cable from, but always look at these things very carefully, like I didn't. I am going to fix that connector, but since we don't have a registration pin, I just turned it one pin clockwise to get it oriented correctly. Now we can test it out. This is very much just a temporary expedient so we can see what happens when we power up, because I can't wait. Here we go. We do have power. Don't have a lot of meter deflection, but I'm looking for smoke. Oh wow. Holy cow. You know, I just realized something. This is not an HW-22, it's a 22. This is the 40 meter version. And I'm okay with that. 40 meters is great. I would love to restore a 40 meter transceiver. Oh, you poor thing. Let's get you out of there. Wow. Scotch tape from the Nixon era. I think this sucker works. I am surprised and excited. Who would have thought this dust-encrusted rig from almost 60 years ago would work? Wow. Don't know anything about whether it'll transmit, but this is a great start. And I think we would be hearing more, except this is a bad night for 40 meters. But we do hear some stations in there. One of the complaints about the HW-22 is it has a pretty narrow range. It only goes from 7.2 to 7.3. I think there are mods out there for extending that, but that's what we got. Well, I'm excited. All right, let's pull the tubes and get this thing in the sink for the sink scrub. And by the way, that dial is in excellent condition. Wow. Damn. Almost looks new. Seriously, it's amazing. I should point out that we can do this because this rig does not have a power transformer on it. If this was a solid state rig or something that had its own onboard power generation, we would not want to do it this way. But because the power supply is external, we can do it. And this is just, man, I'm so used to doing HW-101s and these, you know, the big, ungainly chassis. This sucker is so light. All right, here we go. Oh, just look at all those decades of grime washing away. You're not going to believe how beautiful this board is going to be at the end of this. Oh my gosh. So nice. I mean, even now, without scrubbing it, take a look at that. I mean, already. So there's a lot of grime concentrated in some of these hard to reach places. I'm going to start out by doing just a general scrub with a big brush and then work down to smaller brushes until I get all that crap out of there. Take a look at the difference. This side's unscrubbed. This side's scrubbed. Ajax dish soap. Nothing special. I want to be careful not to get too aggressive because I want to snap off any of these little ceramic capacitors, etc. That big brush pretty much did the job, but I'm going to go in there now with a smaller, more precise brush and just really try to get in there between the components where there's a lot of buildup, and especially in areas where there has been a lot of heat, because that's what kind of bakes on the grunge to the board. And I'm going to call that done. Pretty good. This is what the underside of the PC board looks like, and it's really nice. Not a whole lot to do down here, but let's scrub it out anyway. Oven at 170, and in it goes. I'm going to give it about 30 minutes, and then I'm going to turn the oven off and let it sit for another 30. While that's going on, these odds. This is where an old toothbrush really comes in handy. Much improved. And there it is. Now that it's clean, you have a real sense of what this must have looked like back in 1969 when it was first built. So what's next? I'm going to pull that paper capacitor, these two electrolytics, see if I can find any other electrolytics that need to be replaced. And then I'm going to test every resistor, replace any that are more than 18% above value. And I'm going to replace that resistor. That's the one that was smoking. It's now measuring about 35% off. Yeah, let's get to it. If you've seen my videos, you know my method. I use dental picks. Grab the lead, flip it around on this Lazy Susan, find the pad in question, heat it up, pull it out. How do you know if an electrolytic is good? Well, an ESR meter will tell you. I've got this one attached and it's got no reading at all. It's bad. Here's the other one. Golly, no reading. Okay, two bad ones. Obviously they were working well enough that we heard the receiver coming on, but yeah, this is no good. And by the way, you can check these in circuit. You don't have to pull them. How about this paper capacitor? Let's see. Well, this is 20 microfarads, and it's saying it's good if it's less than 22 microfarads. So I'd say it's borderline. So I'm glad we're changing it. I would have changed it anyway. I don't like paper caps. No one does. They're leaky. They got to go. If you've seen any of my HW-101 restorations, you know that we always replace the carrier null pot. This is a 200 ohm potentiometer, and it has a real strong likelihood of failure. This one is testing 400 ohms, so it's already doubled in value. That's not a good sign. To test these pots, you just measure the outside leads, pins 1 and 3. That gives you your resistance. There are 4 germanium diodes around this transformer. This is the balanced modulator circuit. I'm going to replace those diodes. I do that on the HW-101. Some of my gurus say don't touch it. If there's nothing wrong with them, leave them in there. Other gurus say these are prone to failure, pull them. And I'm going to go ahead and pull them. We're doing this restoration to last the ages. All right, new caps here. These are radials, not axials, but it doesn't matter. A few resistors here and there. We're not testing good, so new diodes. I'm leaving them tall. This is how they do it on the A version of this. I'm not sure why. Here and there, some new resistors, but not a whole lot. The big chore was this guy. I had to adapt a larger 200 ohm pot for that, which it's really kind of awkward. I had to build these pins to come off of it. Looks really bad, but it's going to work. I normally use a 20 turn pot, something like this, on an HW-101. However, that's just too small for this application. The leads are just too far apart and it would have been kind of weird. So I did this and it's going to work. We need to replace that socket right now. And I've tried to get this writing off of there with acetone, it won't come off. I don't know how they etched that in there, but that is now part of this rig's history. So I just happen, miracle of miracles, I have an 8-pin socket. Basically, with recourse to my good friend, the dental pick, I'm going to just loop in on the wire I want to pull, and then I'm going to hold my soldering iron up against the pin until you start to see solder coming out of the end of it. And then the wire just pulls right out like that. And then once all the wires are out, just get a screwdriver or something and pop out this aluminum retaining ring. And it just slides right out. Make sure the little registration tab is facing straight down. And then lock in another aluminum retaining ring on the back. Boy, that's a whole lot easier said than done. It is a pain. You'll see there's a little indentation here, and you want to pop that retaining ring right in there. But that retaining ring has a mind of its own, and it wants to pop out and hop into your lap. So good luck. Probably the best way to do it is to separate it like this. Start with that lower end, get it in there like that, and then take a screwdriver and just start mashing it all the way around until you can pop this side right in there. Sometimes it's easy. Last thing you do is be sure to use the screwdriver and shove that ring in there. You don't want this thing popping out. I copied these illustrations from the manual, but as you can see, this one's really kind of hard to follow. So what I'm going to do, I should have taken a picture of it, but what I've got here is the 20-meter version. The wiring is the same on the socket, so I'm just going to follow this one. But yeah, it might be a good idea to take a photo of it before you strip all the wires out. Okay, everything's in. Took about 30 minutes. I'm just going to test, make sure everything's nice and snug. Don't want anything popping out. I don't know if you can see that set screw. Well, I've noticed this thing is rubbing, and there's just not enough room on the shaft to slide this thing back away from the faceplate. So I think what I'm going to have to do is just build this front panel out just a little bit, maybe put a washer in there just to give this thing a little bit more freedom to turn. Because right now it's just starting to bind against this front panel. And I haven't even put in the replacement window yet. There we go, a little bit of extra space there. And now we've got freedom of movement. And I'm going to install one of these. This is from Mahoney's Radio. Got this on eBay. Been rewiring this 8-pin plug, and I figured out why the previous builder got these wires crossed. The pin numbers actually fall exactly between the pins, so it's easy to get them mixed up. See where the 4 is? It's just, it doesn't lean to one side or the other. It's right in the middle. So you just have to figure out, okay, pin 1 is going to be the first one to the left of that registration slot. So I've got it wired correctly. Now let's plug it in and see if it works. All the tubes have been cleaned and tested. We've got good freedom of movement here with the dial. And I've got the clean knobs put back on. So let's turn it on and see what happens. This is late afternoon and the band is dead, but I'm going to come back in a few hours, try it again. I think we're good to go as far as the receiver goes. So here's our first problem. We've got no relay action. And checking the manual, I see that V2 is the relay amplifier tube. And this tube is cold. And I'm not sure why. So I'm going to run a voltage check, find out what's going on. So I checked my voltages for V2. All the DC voltages were just fine. However, I checked the AC voltages for the filament, and it was a little weird. There was 13 volts on each side where there should be around 6.5 on one and just about nothing on the other. Okay, problem solved, and that tube is lighting up. How did I do it? Well, I went back to the filament string and at the bottom of the schematic. So you have the 12 volts and then the filament common, and the tubes divide the voltage between them. So these tubes need roughly 6.5 volts, and there's roughly 12 volts in the system, 13, 14, something like that. And so they split the voltage. I went back to the beginning of the filament string, started out here. I thought maybe there's a problem with this choke. These are the finals, V6 and V7. When I measured from this point to this point, I had 14 volts. And if I measured from here to here, I had 14 volts. But if I measured from here to here, I had nothing. And so I knew that AC voltage was not making this track through the finals. And so I thought, well, there's nothing in between them that could be breaking the circuit. So there has to be some kind of filament short in one of these tubes, even though they tested good. So I swapped them out, and now it's working fine. Well, here's an update. I popped the old tubes back in, and guess what? It's working. It's possible that by removing the tubes and putting them back in, I was able to clean a crusty tube socket or something. I don't know. It's a mystery, but it's working, and those are the original finals. So I think I'll pop them out again and really clean those tube sockets. But anyway, we got a working rig now. I just wish 40 meters would come alive. Well, the receiver's working fine, and now I would like to calibrate the dial because I know it's got to be way off. If you remember this thing, I'm going to plug this in to the calibrator socket. Pull this out. Tube's going to light up. That was fast. All right. Get a tone at either end of the band. So let's zero beat it right on the mark using my alignment tool. I'm going to put her there and try to get a zero beat. Okay. Now if we go to this end of the band, why is it off? Well, there's a trimmer screw on the VFO variable capacitor, and basically what it does is it takes the band and it kind of shrinks it like an accordion or expands it. So I'm going to have to tweak that, and that is located right there. So I'm going to adjust it and then keep running the calibrator back and forth until I get exactly right so that the dial lands on 7.3 and 7.2 at a zero beat. You can go back and forth and back and forth and back and forth in this process until you are out of your mind. Okay, now for receiver alignment, and I'll tell you what, if you've ever aligned an HW-101 or one of those bigger transceivers, you'll find this blissfully easy. I'm using the manual. Receiver alignment is essentially adjusting coil T3. That's it. Wow. And T3 is, where is T3? That's T3 right there. I'm going to use the calibrator. All I'm going to do here basically is go for the highest reading. So, and this has two slugs. There's a top slug and a bottom slug. So we simply adjust the top and the bottom So I'm doing both slugs. Do the top one, the bottom, and then come back and do them both again. Receiver alignment's done. VFO calibration, that was easy. And then finally the transmitter alignment. A little more complicated, but I mean, man, compared to some of these other rigs, it's a breeze. And the rig is done. And happy to report, test 1, 2, test 1, 2, 3. Full output. And of course there's no one to talk to because 40 meters is dead. Just to be sure, I'm checking things out on my Yaesu, which never lies. There's nothing happening. Not in that spread. Oh, there's a little bit. Yeah, he's in there. There's just a lot of noise. Well, what's next? How about clean up this cabinet? I'm going to use this Heathkit green, which is something that I had formulated. I sell it on eBay and on my website, in50la.com. And first of all, I'm going to go ahead and just give these a light sanding. I like to do these in pairs. I'm going to just sand it enough so that the paint has something to stick to, and give it a few hours drying time. One last look before we say goodbye forever. There it is. What a beauty. Look how nice and shiny that front panel is. Wow, love it. Looks good with its new paint job. Tell you what, I think these rigs pack a lot of punch for what they are. 100 watts output? Man, that's awesome. And the thing weighs like less than 5 pounds. It's incredible. Definitely a cool piece of late 60s ham radio history. One little postscript. I saw someone online mention, hey, I'm putting it in tune and I'm only getting 5 or 10 watts out. Well, that's by design. This rig in tune only gives you about that much. And you can adjust it. There's a tune level control in the back. But they do that so that if you've got high SWR, you can correct it without damaging the finals. So yeah, when I put this in tune, that's about the max I'm gonna get. And again, that's by design. That's just to protect the finals. So I think that's it. 73.